Hello?
Hello.
All right, good. All right, so this is idea of a limit for the calculus. This is actually the second part of 1.1 into the lesson, and hopefully my microphone is working because it's awkward if it's not. Anyway, all right, so idea of a limit. So when being asked a question, what does it mean for a function to have a limit as L approaches x from some fixed number c? To answer the question, we need to be more precise about the function L and c to have a limit at c. Now, I'm going to go back to something that we talked about yesterday. Yesterday, we were talking about this right here. Okay, and we actually had someone answer that question. Why could I not find the slope at a single point right here? Why could I not find that? Yes? It'd be undefined. It'd be 0, right? So it would be whatever it is over 0. So what we're trying to find is finding it at that point, and that's what the limit process is. We're getting into something where the denominator is going to be undefined, or in some other case, other things. So right now, the basic of it is where we're not going to have it. It's possible that we could have a number there, but no. Anyway, so right here it says to have a limit at c, the function f must be defined at everywhere in an open interval containing the number c, except possibly at c, and L must be a number using these restrictions. We introduce the notation. Okay, here it is right here. So as x approaches c, the limit as x approaches c of f of x is L. L is the limit. On occasion, it's just going to be the y value. Just going to be plug in the x and we get a y value, and that's it. Okay, on occasion. But other times it's not. You get something interesting. Okay, which is read the limit as x approaches c of f of x is equal to the number L. The value of f of x can be made as close as we please to L for x sufficiently close to c but not equal to c. If it's equal to c, then it's undefined. Okay, you guys take a look. Read this, please. All right, reading that, what's that say? In words.
As x approaches -1, then x squared minus 1 over x plus 1 equals -2.
So you would say that the limit is, very good, the limit is -2. Now, can we plug in -1 to that?
No.
Why?
It'll be 0 at the bottom.
It'd be 0 to the bottom. It'd be undefined, right? So, there is ways of doing this in which that we are finding the limit for this to work out. Okay, I'm going to show you guys some fancy magical math. You guys want to see that? Okay, I'll show you some fancy math. Okay, now listen. I'm about ready to drop an F-bomb right now, so if you guys haven't heard this before, I'm sorry. Okay, I use colorful language all the time, but you guys need to factor. Okay, so we need to use the F word on this one, so factor that. Yes, so I said the F word. Factor. You guys get it?
Yeah.
It's a math joke. Okay. Anyway. All right, what's the numerator factor to be? X plus 1. X minus 1. Okay. And then the bottom is going to be x plus 1. Now, you guys took some algebra classes, hopefully, before taking this one. What can I do with that function right there now? I can cancel, right? Now, this is actually going to be called a removable discontinuity. Because if I plug in -1 to my function as is, it is undefined, isn't it? But if I'm able to factor it out and take it and be able to still do it, it's called a removable discontinuity. Okay? So, bam, bam. So now it's going to read the limit as x approaches -1 of the function x minus 1, and that's going to give me, I can plug it in, -2. So, interesting math, neat math, okay? So back when you're doing algebra, you didn't realize, hey, this is same as calculus, right? You didn't? Okay. Anyway, but so. All right. Okay, investigate using a table. So y'all got calculators right now, right? Okay, so I want you guys, try this out. You guys are going to fill in yours, because you guys actually have it on yours also. If you can't put it in a little box and put it off to the side, fill those in. So I want you guys filling this out from the left and from the right. So start from the left, and then start from the right. Left, right, right. Okay, because I'm trying to get you guys to the point where you can't, a lot of times this number right here is not going to exist. So you can't jump straight to that. Okay, now I'm going to show you guys this cool trick. Okay, so I want everyone paying attention. This is a calculator trick. This is special to this calculator right here. So I have this. I'm going to, okay, so this is home. This is your start screen. This is where you're going to actually start everything at. Okay, this button over here is your scratch pad. Hit that once. You get here. Hit that again. We're right here. Okay, scratch pad, we're hitting that. Now, my function, what was my function? So 2x, oh crap, that's y, doesn't it? X plus 5, yes? Okay, so I'm going to hit enter. Okay, quite often you're going to have some interesting looking function. Okay, and it's usually going to be not able at that value. So now that's there. Okay, if I hit scratch pad again, now I'm over here. Okay, I'm back on this. So you guys are gonna, there's this button right here that says vars. See this right here? It's right below the little mouse pad. Hit vars. And it says F1. So that is the function that you put into F1. Okay, so we're going to evaluate at the function F1. And what was my first number I said to do? 1.9? 1.9. Hit enter. There we go. And then I said do it from the other side, right? What was the other side? Vars, again, my function. It was 2.01. Yeah. Like that? Yeah. Okay, good. Bam. There we go. Now, you guys are going to fill in the rest. Oh yeah, it's supposed to be 1.99. Yeah. Ah, dang it. Okay, so. See?
When I press vars, it doesn't do anything.
Did you put the function in first? Oh no, you have to get out of that. You have to be in that one. The plain white one, not the graph. Hit plain white one. There, that's where vars works. Okay, you already had a function there? Okay, so now you hit tab. Get rid of that one. Okay, so now go ahead. All right, if you guys got a bunch of weird stuff in there already, you can hit the dock button and the letter B. You'll clear all your scratch pads. Doctor. I thought I was going to see 7. Okay.
Because it'll be a perfect time after they fill in this table.
I have another one for that same reason that actually does, for the same reason.
I'm kind of pissed off when my students don't voice what they know.
That's all right.
I know it's not. But it's hard. He's weak-minded.
Yeah. All right. First box. 1.99 knows what? 8.99. What was 1.999? 8.999.
It was the last one's 8. Yeah.
Okay. What about this one? 8.9998. Okay. Okay, so let's go over here. This one was 02. What's this one? 2, like that? 9.2, like that? Okay, so looking at it mathematically, the left side and the right side are both approaching a single digit, isn't it? Looks like the left side is approaching the number 9, right? And the right side is also approaching the number 9, right? So they're both approaching the same number. So this one right here is special because there is no there is no domain restrictions, or for my case it would be a hole, right? Okay, so there is no domain restriction, so I could have just plugged in 2 and called it a day, right? But, you know, for the sake of what we're doing, my left side and right side are both approaching what number? 9. Yes, that's what I'm trying to get. Okay, let's take a look at this. So, left hand and right hand. So, the different notation that you see right here is the minus sign. That's important. So that's a limit as x approaches c from the left. Because if you think about a graph, the negative numbers are on the left, right? So a negative means the left. And on the other one, the graph, the regular Cartesian graph, okay, positive numbers are going to be on the right-hand side. So that would be the limit as it approaches from the right. Now, a left hand or right hand, that means that you don't have to have both of them. We talk about this right here because sometimes a function is not going to exist on both sides. Okay? Functions that don't exist on both sides. Let's say my function f of x is equal to the square root of x. What is your domain restriction here?
No, x can't be like less than 0.
So you're saying,
X is less than 0. Something like that.
so x has to be,
Okay.
there we go, equal to 0, right? So x would have to be greater than or equal to 0. So now, this one right here would have that type of left hand and right hand type of thing. So I would not say I would be able to find the limit, the regular limit, because what we were talking about, okay, the regular limit is from left and right. Okay, left and right both going to the same number. But in this case right here, it is not possible to find it at that number because it doesn't exist. So the only type of limit function I could do on this would be from the right-hand side. Okay, from the right-hand side, graphically, it's going to look something like this. Okay, it's going to be like that, right? So from the right-hand side, as it approaches, we get to there, which is going to be, trying to get into there. See? Okay, so now, Doctor, can you please ask that question again?
What was your target value when you were talking about the limit of the function square root of x?
Yes, so in this case right here, that would be that my x would be approaching 0.
But if your target value was
Okay,
4,
so c equals 0, In this case right here, x would only be able to approach it from the right-hand side from there. But if we're talking about somewhere over here, is there a left and right over there?
Yes.
Yeah, there's a left and right from that. We're just talking about stuff that doesn't exist on the other side. All right. Okay. I want you guys to try this one again. Okay. And I'm going to show you guys how to clear out the calculator. So you guys could do this real quick. So I'm going to go back to my graph, hit the tab button, and we'll bring up this. So arrow up, delete that one. And to set up your fraction, this is really neat with this calculator. Set up your fraction, you hit Control, divide. That will set up your fraction there. Okay, and that was e to the x, right?
Yeah.
Plus 1?
Minus 1.
Minus 1. And that is over x, right?
Yeah.
There we go.
So Mr. Pacho, when I did that, my -1 was in the exponent.
You did?
Yeah.
Ah, dang it. Tab, there we go. Your -1's in the exponent?
Yeah, when I typed it, my exponent -1 was in the exponent.
Uh-oh. So all you have to do is make sure you arrow over from here. So, but when you do it like this, the calculator does it for you. So if you have the 84, it does it differently. All right, someone asked a question that I just got sidetracked.
Sorry.
Anyone struggling? Okay, so what do you do now? Okay, so remember bars. So no, because if you clear it, you clear your other one too. Yeah. Bars. Yep. That one, yep. Okay, F1. Plug in your number. Yeah. I think you could actually get it as you go in. It should be like tens, hundreds, thousands, and then so you can actually see where it's approaching. Okay, so once you get to a point, you should be like, oh, hey, it's approaching this number. Okay. So I'm gonna do this doc B because I don't know what's wrong with yours. So and All right, let's see what we got here. So, in this case right here, my C value is 0, so we're trying to approach to see what it's going to happen at 0, right? So, as we're filling this in, at this right here, what do we get at negative 0.01? 0.99. Okay, next one's going to be 999, and then it's going to be 0.9999, right? Okay, same thing over here. It's going to be 1.005. Okay, or it'd be 0.1, right? And in this case, it would be 0.0005, right? And so now, left and right hand side, what can I say that's approaching? 1. Yes? Okay, so that's approaching 1 there. Both left hand and right hand is going to be approaching 1. Okay, so by the sound of that upstairs, that means that we are running out of time. So I'm going to continue this tomorrow. Okay, don't forget, like, share, and subscribe. Hit that notification button.